Alrighty, so segments are a type of line, and we're going to talk about some definitions and properties that go with segments. So the first definition that I have for you might seem a little bit obvious. It's a point, and a point is something that has no dimensions. That's what defines a point. Is it something that has no dimensions? It's a dot. Okay, we symbolize a point with a letter. So this is point A. Okay, so we would write A. That's a point. We use points to create lines, and lines extend in one dimension. Okay, if I have 2 points, A and B, a line is going to go through them and it's going to go on in both directions forever. We would symbolize this line with A, B, and then arrows going in both directions. So lines go in both directions through at least 2 points. A line segment is a line with 2 endpoints, meaning it does not go on forever. So I might have letters C and D, and those are my endpoints, and I symbolize that with C, D, and a line on the top with no arrows because it does not go on in any direction. It ends at the endpoints. Next we have a ray. A ray is a line that comes from one point and passes through another. So I might have point E here that it starts with, and I have point F here, and it's going to start at point E, but it's going to go through F and continue. So I have E, F with a line over the top and an arrow going in one direction. The arrow always goes in the direction that that point is passing through. So if it starts with E, it's going to start with E and go through F, so F comes second. Next, we have a word that's related to that. We have the initial point. This is the point that starts a ray. Starts a ray. So again, if I have E and F and they make a ray, E is the initial point because it's that point that we're going to start from. All right, last definition that we have is congruent segments. Congruent means the same. So congruent segments are segments of the same length, not necessarily the same direction. Okay, so any 2 points, if I have point A and point B, and that makes a line, and I have C and D, and this is 2 centimeters, and this is 2 centimeters, then A and B is what we call congruent to C and D, and this symbol here represents congruency. Okay, that's our congruency symbol. And we'll use that throughout writing proofs. Okay, so now we have a postulate, and a postulate is like a property, it's like a rule. And the ruler postulate says that if 2 points align with numbers on a ruler the difference in the numbers is the length. That's not how you spell length. Length is the length. Okay? What this means is that if I have a segment and I line up my ruler, here's my ruler, and I have a mark at 3 centimeters and a dot at 5 centimeters, then my length of segment GH is equal to 5 minus 3, which is equal to 2 centimeters. It basically means we can use a ruler to find the length of a segment. Okay? Our next rule that we have is the segment addition postulate. And it says if B is between A and C on a segment, then AB plus BC equals AC. Part, whole. They come together to make the whole length. So if I have point A here, point B here, point C here, and they all make a segment, okay, and this is 2 inches, and this is 1 inch, then the total length of AC is equal to AB plus BC, so it's equal to 2 plus 1, or equal to 3 inches. Units are important. Use your inches or centimeters. Okay, then I have an example that uses this. So find AC given that AB is 4 and BC is 10. So I know that AB plus BC equals AC given that AC is a segment. So 4 plus 10 equals AC. So 14 centimeters is equal to AC by the segment addition postulate. That's that if-then statement that says if B is between A and C, which it is, then we can add those pieces together and get the total length. All right, one more example. Find JK given that KL is 5 and JL is 7. So, given K between JL, a line segment, then JK plus KL equals JL. So JK plus 5 equals 7. JK equals 7. Nope, not 7, 2. And we don't have units this time, so it's just 2. By the segment addition postulate. Some things I want to highlight here. I said given K between JL. This is what says that I can use that segment addition postulate. Given that we are a line segment also is necessary in order for us to use that segment addition postulate. So both of those things are required to be stated for us to use the segment addition postulate. I didn't do that well in the first example, but we should always be saying, what are the conditions that I have that allow me to use the segment addition postulate? And then once I get my answer, I say I got my answer by that segment addition postulate. So we're giving the context that says that I can use that postulate.